Hello everyone. So today in this runtime world generation system, we are going to implement a function to remove grass instances or whatever the bushes that we generate using the grass spawner when the character moves away from the already spawned tiles. So let me explain that. So here you see when the character moves around, when the new tiles are added, these red tiles, they are new tiles added, and those blue tiles, they are the tiles that are removed. So when you see a red tiles, that means within the area that is covered by that red tile or box, grass instances are placed in the land. So because of culling, we don't see them in the further away, but they are there. And when we see a blue tile, that means when the character moves further away, those tiles are the instances of the grass meshes are removed from those tiles. So if I enable toggle debug camera and go there, you will see after this line there are no grass meshes in the world because the character is over there and the character don't see them, so there is no reason to keep them. So yeah, that's what we are going to work on today. The reason to implement this system is hopefully that would help us to regain some of the performance. And before we get started, as always, I'd like to remind you that you can download the project files of this project and all other thousands of projects that I have done in my channel from the Patreon page. Once you become a member, you can download anything without a limit. So link is in the description below. Feel free to check it out. And let's get back to today's tutorial. Alright, now to get started, first let me open the world blueprint, BP world. This is the blueprint that is responsible for spawning all those grass instances, bushes and everything, basically generating the world. And this blueprint is a child class of this world generator C++ class that I have implemented. So let's go here. Now in this object spawner, I have this update tiles and update tile. So these are the functions that I use to add grass instances into the world using this spawn object. So now this removing instances from the tiled object spawner is not only relevant for grass, that would be relevant for everything that I am planning to spawn. It could be animals, it could be other maybe resource types, rocks or whatever you want. So I will implement that also in the object spawner. So that has to be a blueprint callable view function, and I'll name it void remove far tiles, because we only want to remove the tiles that are further away from the character, hence the name. Okay, now let's implement this function here. So I think when we update tiles, before we update the tiles, we should call remove far tiles, so that the tiles that we don't need will be already removed before we add any new tiles. So let's start implementing now this remove far tiles. So first thing we need is we need to access the location of the player. So for that we already have a function. Let's call this player Sarah. and we can get this with getPlayerCell function, which is already defined. So this will return the location of the tile that belongs to the player character. Correction, the location of the tile that the player character is currently in. And we already have this spawned tiles array, F-vector2D array, which holds XY locations of all the spawned tiles. So if I iterate through these spawned tiles and compare the locations of those tiles, and if they are further away from the player, we can mark them as far tiles and then think of a way to remove them. So for that, I need to iterate through spawned tiles, and also I need to remove tiles from that as well. But it's not a good idea to remove the elements while we are iterating through an array, because that can cause inconsistencies in the loop. So therefore I'll add a new array, t-array, in the same type as the spawn tiles, f-vector2d tiles copy, spawned tiles copy. And to add the spawn tiles to this spawn tiles copy, we can use this function, spawn tiles copy, spawned tiles. When we append it, all the elements in the spawn tiles array will be copied into this spawn tiles copy, and it doesn't have anything else at the moment, so it will only have the elements in spawn tiles. Then we can add a for loop, int tile index length spawn tiles copy dot now and tile index plus. So now using this for loop, we can iterate through elements in the tiles copy. Now to calculate the distance between this current tile that we are iterating through and the player's location, I'll add another F-vector2D relative tile location equals tiles copy, spawn tiles copy, tile index, and subtract F-vector2D. We need to cast this player cell because this is a 3D vector. Okay. Now, if you remember, when we generate tiles, this is the function loop that we were using. So we use cell size multiplied by 0.5. Not this one. This one. Cell count multiplied by 0.5, and to get the actual location we have to multiply it by cell size as well. So we can use the same type of logic to determine if a tile is further away from relative to the current player's location that would lie within this range or set of tiles that we would be calculating. So I hope that would be clear when I implement this. Let's have a if math. I'm going to consider absolute value because it could be either plus or minus. Relative tile location dot x. If this is larger than cell count multiplied by 0.5f multiplied by cell size. This is only x direction, so we can have it like this. Or the same thing but for y. So y. So if x component or y component is larger than this value, the product of these three values, that means this tile, the current tile that we consider, would lie outside of the range that we consider as the tiles around the player. So that is something we should remove. Now here, when we add the tile, we use this update tile. For that, we use this hit location. So hit location means we do a line trace to determine the location on the ground relevant to that tile. So we will have to do the same thing here as well, because in order to remove that tile, we need to know the center of that tile, and then we can calculate the grass instances or whatever the objects that is spawned within the bounds of that tile. Then we can remove it. So let me just copy this and paste here, but here we don't have this tile center, so we can add it. Vector tile center equals f vector tile spawned tile copy tile index, and this would give us a 2D vector. Now as the Z component, I'll use player cell dot z. Okay, this should be capital. Alright, now here if we get a hit, if we hit, now we have a location of the tile using this hit dot location. So now it's safe to remove spawned tiles. From this spawned tile, let's remove the element, the current element, which is spawn tile copy tile index. And so this, what is this doing is it just remove the spawn tiles reference element from this array. It does not actually remove anything else. For example, it does not remove the grass instances. So for that, I'll add another function here, just like this update tile. We need to give the tile center, but here instead of update, we need to remove. So remove tile, and also I should be able to override this function from the child classes. That means in this case from the grass spawn. So I'll mark this as virtual and create a definition here, but we don't need to add anything. Write the remove tile logic here. Okay, now let's go to the grass spawner and we can override that. Void remove tile. Let's just copy that. Alright. Okay, now let's implement it. We didn't test anything in a while. So just like we draw a debug box in red for the tiles where we update or generated, let's add another draw debug box here and make it blue, and also here we can call remove tile, and the tile center means hit dot location. Okay, before we write the removal logic for the grass, let's compile and make sure that we don't have any errors. Okay, live coding succeeded. Let's see. Here we got the red boxes. Now let's move further away and we are getting blue boxes. That means the tiles are being removed over there. Tiles, we haven't wrote that yet, but the logic is working. Yeah, nice. Alright, now let's go back to the code and write the actual logic to remove grass instances. So how do we do that? So in this grass spawner we have these foliage components which hold references or pointers to you-instanced static mesh component. These are the static mesh components that I use to add grass instances, and these are the foliage types. So whenever I remove instances within a tile, I have to remove the instances of all foliage types for that tile. So that means we have to iterate through either these components or these foliage types. So that means, let's go here for int foliage type index. Let's use component index, and the length is foliage components. No, which is that array I just showed you. Now, to make this simpler, you instanced static mesh component foliage component equals foliage components foliage component index. And also we need a way to determine what are the instances that lies within this tile. For that we can use this foliage component get instances overlapping box. So we can give a box and see and get a list of instances that lies within this box. So for that we need to have a box. So let's define it over here. Oh, one more thing. To make this code future proof, I'll call the super tile function as well. For now I don't do anything in the super function, that means this one, but just in case I have to add something in future, it's better to call that. Okay, so in order to define a box we need two vectors, min vector and max vector. So f vector equals vector, we have the tile center, and to this let's add f vector 1 multiplied by cell size multiplied by minus 0.5f. So this would give us the minimum vector of the box that contains this tile center. Similarly, another one, max. Here instead of minus, this should be plus, or we could just add a minus here and add a plus here and keep this same, but it's all the same. Alright, now f box equals f box, we need to give min and max. So min max, right? Oh, one more thing, we need to make sure the height of this box covers the possible area. So let's see, I'll set it as tile center plus c, or is it minus base distance. So this is the value that defines how far we do a line trace when we try to determine the landscape. Similarly, max.c equals tile center dot c plus trace distance. Okay, now we have a box, and now we can use this. Get instances overlapping box, we need to give the box, and it is in world space, so true. Now this returns an integer array, so to catch it, the array int instances equals this function. Okay, now for the big trees I did implement a pooling method instead of just removing, so maybe it would be useful to do a pooling method here as well rather than just removing. But first let's test removing and see how it goes. If required, let's later on implement instance pooling method as well, so that instead of just removing them, I will be relocating grass instances in the newly added tiles rather than just adding new instances and deleting the older instances that are in the far tiles. But for now, let's just simply remove them. Instances dot num is larger than 0, because we need to make sure we got some instances before we try to remove them. So if we got any elements here, foliage component remove instances. Alright, that's all. I think let's compile and see. Yep, no errors. Okay, alright, but it's in the ocean, it's in the water, so we shouldn't get any process there anyway. Let me speed up. Yeah, okay, now let's see. Let me enable the debug camera and see. Yeah, you see, now we don't have instances here, so they are removed because they are further away from the player. Okay, so if I move closer again, they should be added back. Yeah, see, they added back. Alright, so, and from the behind they are removed. So okay, so things are working well. Let me set stat draft so we can see how is the performance. You can see the performance graph in the bottom left. And as the new tiles are added, older tiles are removed, and we barely see any performance spikes. So that means, let me enable the FPS counter as well. It's 120 at the moment, so everything is working great. Okay, so yeah, I think with this we can stop this episode right here. So for the moment I don't see a requirement to implement grass instance pooling method, but maybe in future if needed I will add that. Alright, thanks for watching. As always, updated project files will be available in the Patreon page for the download. Link would be in the description below. And let me know what else you guys would like me to cover in this series in the comments. And see you in the next episode. Goodbye.